Hey Techno Studs, it is time for the main event, at least for this module, and that is access control lists. So let's talk all about access control lists, what they are, what they look like, and how we configure them. So let's jump into access control lists. In this module, we're gonna start out by talking about ACLs and what they are. We're gonna get into different types of ACLs that you could implement on your devices. We're gonna get into the process of how your router and how your firewalls use ACLs and what process, what order they do that in. We're gonna get into creation guidelines when you're creating these ACLs, and then we'll wrap things up by talking about placement of the ACLs. Where would we place the ACLs? One thing to note is that ACLs have a lot of purposes and they can be put on a lot of devices. So you could possibly put that on your firewall or your router or even when you're layer 2 switches. Now layer 2 switch is not going to block traffic that's going through it to these different devices. They're layer 2, it's operating on layer 2. But we could use it to block access to the management port on this, or the VTY ports, and we'll actually be covering that. We can also use ACLs to define what's going to go through a VPN on our firewall. We could use it on a router for packet shaping and policing, or we could use it as control to our different networks. So we want to maybe block or allow certain traffic to different devices on the network. So ACLs have a lot of different purposes. We're going to really primarily cover one during this course, and that is to block traffic going through these devices. So we're going to be using a router, and we're going to be setting up an ACL on the router that's going to stop certain traffic that's going into the router or going out of the router. So an access control list is a list. So then the question is, what is it a list of? Well, it's a list of access control entries or a list of access control statements. So it goes by many different ways. So what is an access control entry? This right here, all of these combined, is an access control list. And to be specific, it's an access control list for numbered 42. And they are made up of these access control entries. So each one of these is an ACE, or a access control entry. So this is an ACL and that's an ACE. Well, what are these entries doing? Well, each one of these entries is either going to deny traffic or permit traffic. So in this particular case, we've got an access control list, and it's access control list 42. And the first entry denies host 10.1.1.5. So it's going to stop traffic from this source right here. And then it's going to permit anything from the 10.1.1.0, and it's got a wildcard mask here. So it says anything else from that network, it's actually going to permit. So what is the reason for ACLs? As I mentioned earlier, there's actually many applications. Whether we're defining what traffic is going to go through a tunnel or a VPN, or whether we're shaping or policing traffic, it has a lot of different purposes. But for this purpose right here, we're just gonna say the purpose of permitting or blocking traffic across this network. And really, we're going to be implementing ACLs for a few reasons. One of them is because of security. We want to secure certain networks. We want to secure certain traffic. And so we want to put an access control list for security purposes. But another reason for this is we want to put ACLs in to limit certain traffic. And so here is a network right here, and let's say this is a web server. And so we want port 80 and 443 to be open to this web server right here. So perhaps we're putting an ACL on this for security purposes, so that way people can get to port 80 and 443, but aren't able to get to other resources on this network that we don't want them to get to. So that is one of the reasons. So we put it on this device right here for security purposes. We would put it on this device right here because maybe we want to stop traffic from ever going across our network to this other network. So as an example is maybe I want to have access to this port 80 and 443, and I want to have access, or I don't want to have access to the other devices on this network. So I created an ACL for that. Rather than putting it on this device for security, I could put it on this device over here to stop the traffic so it doesn't go across and utilize these resources across the rest of the network. And maybe that these are slow connections and I really need to limit how much bandwidth is going across there. So that's where I'd put the ACL on this other side. There's a major division in the type of ACLs that are out there. There are standard ACLs and there are extended ACLs. Both can exist on the same device. So what is the difference between a standard ACL and an extended ACL? Well, let's talk about a standard ACL first. First, what we see is that it's just specifying an IP address or a network right here. One of these specifies a host and one of them specifies a network. So each access control entry only specifies one address essentially, and it could be a network address or it could be a host address or so on and so forth, but it only specifies one. This is the source address. And so it specifies the source address. Another thing that it does not specify is we see nothing around the port numbers. So it's only filtering based off of layer 3 IP information. And so how else can we tell besides this that this is a standard access list? Well, the number gives it away as well. So we know that standard access list will be 1 through 99 and 1300 through 1999. So if you see these numbers right here for the access control list, then we know that it's a standard list and we're only referencing the source IP address. All right, compare that now to an extended where we see both a source and a destination. And we see a source here and a destination. The NE just means everything. So the host specifies a specific host, so we don't need to have the wildcard mask if we put a host in there. And then we see the destination here is a network that's right there. So that's one of the things that we see is we have both a source and a destination, and we also include the port that's being allowed. In this case right here, it's port 80 that's being allowed. This is the protocol that's being allowed. So you can see it could be TCP, it could be UDP. So it's permitting or denying certain protocols and certain ports for those protocols. And then one other thing that we see here, similar to a standard list, we see 180 right there. And that's because a extended list would be 100 through 199 or 2000 through 2699. One other thing too is we're going to get here into a second where it could be named or numbered. So we'll talk about that as well. But so that is going to be one of the big differences here between standard and extended. And we're going to cover more on both standard and extended and where we may use both standard and extended. So as I mentioned, there's also ACL numbered, and we saw that the numbering is different for a standard versus the numbering is different for an extended. But we also have numbered versus named. So numbered is just like what we saw. You give each statement each ACL statement specifies what access list it's a part of. And so that's how it knows that it's part of an access list. So it's a little different when it comes to a name. You're going to type in access list, and since it's not a number, you have to say whether it's standard or extended, and then you give it a name. And once you give it a name, then you are in the mode to edit that access list. And so the way you're going to edit that access list then is to put your deny and permit statements in there just like that. So it behaves a little differently. So when we get into our demos, we'll actually demo them separately so you can see the differences between the two. Now, it's very important to understand how ACLs get processed. If you don't understand how ACLs get processed, you can very easily create an ACL that's not going to function the way you think, either opening up a security hole into your network or creating people so that they can't get into your network. And so what an ACL does is, first of all, a router, let's say it's coming from a router perspective, and we could put an ACL whether it's coming in on a port or whether it's going out on a port. So let's say in this example right here, it's coming in on a port. So it's going to come in on a port, and what the router is going to do is take a look at the packet and take a look at the source IP address. These are all standard, so it's just taking a look at the source IP address in this case right here. If it was an extended, then it would be the source and the destination. But since this is just a standard, it's taking a look at the source, and it's going to compare that against this list. And so let's say it comes in and it's 10.1.10.23 is the address that has the source address of this packet that's coming in. Then what it will do is it'll take a look at each one of these in sequence order. So it's going to take a look at the first one, and it says, is 10.1.10.23, is that the same as 10.1.10.13? No, it's not. So it's not going to process it using that one. Then it's going to take a look at the next one. Is it 10.1.10.0, and with a wildcard mask is 0.0.0.255. And in this case, it says, well, yes, it is part of this network right here. So I am going to take this action right here. And this action says it's going to be permitted. So now this packet is going to be sent through the rest of the device and get processed like it would or just any other packet that's going through the device. All right. The rest of this access list is not used in this example right here. So one of the questions you may have is what's going to happen if it goes through all the way through the list and it doesn't match anything? Well, in that example right there, what's going to do is it's going to deny it. There is what's called an implicit deny any at the end of an access control list. And so that implicit means that it's not stated, it's not overt, it's not something that you're going to see show up in the access control list. And it's a deny, so it's going to drop the traffic, and it's any, so it matches up against this. The any means that everything. And so there is an implicit deny any that will drop all other traffic if it doesn't match any of the other access control entries. I know I've mentioned this before, but making sure that your ACLs are correct is going to be really important for your network. The problem is the wrong ACL can block traffic that should be getting to certain destinations, causing a lot of headaches to your end user and causing a lot of problems on your network. And vice versa, an open network putting the wrong statements in the wrong order or on the wrong interface just nulls that ACL and can cause a lot of security risks on your network. So make sure that you get your ACL creation correct. So how do we do that? Well, first of all, there should be some sort of policies that back up what you're trying to do with an ACL. A policy is something that states how you're conducting business, how you are configuring these things. You should have policies that talk about what security are you trying to implement and how our things should be implemented. So a good ACL starts out with a good policy and how a good policy is set up. And then from there, you can use like a text editor to start typing out all of your, so what I would usually do is bring up like Notepad, and you've seen me do this in demos where I type out all of what I want to apply. I'm going to do the same thing when it comes to ACLs. I'm going to put all of the ACLs on a notepad, get it all typed out, make sure, go over it multiple times, maybe have somebody else, probably have somebody else check it out to make sure that, that it is correct and it's going to do what you want it to do. You have to determine ahead of time, go through this process to determine ahead of time what you're trying to accomplish with it. So, and then there's a remark command, and we will get more into the remark command, but you can actually document within the running configuration as you're creating the ACL, you can actually document what each of the statements do. So we'll talk more about the remark command, but that is a good command to use to document. If it, at all possible, have some sort of test network that you're testing these out on before you're actually putting it into production. So that way you know that it's going to function as you desire. Once you put it into production, also make sure that it's working correctly. Once you've created the ACL and you've actually put the ACL on the router, it's actually not going to do anything once you first initially put it on the router. That is not until you apply it to an interface. So once the ACL is created, we actually have to apply it to an interface. And we apply an ACL to the interface in a direction, and that is per protocol. So what do I mean by that? Let's use this router as an example right here. It has 3 different interfaces on it. And so there's the interface right there, and it's per direction. So on this interface, we could have an ACL that's filtering the traffic coming into it. We can also have a ACL filtering the traffic that's going out of it. Same thing with this interface right here, and filtering the traffic coming in and filtering the traffic coming out. And same thing with this interface right here. So far we can have up to 6 interfaces. We got per interface, per direction. We also have to have per protocol. An example of that would be IP version 4 and IP version 6. So for each one of these, I could have, for this interface right here, IP version 4 and IP version 6. Same thing for this interface right here and this interface right here. And so since we could do that for each of the directions, now I've got to take 6 multiplied by 2. I can have 12 different access control lists working all at the same time on this router right here. So 1 access control list per interface, per direction, per protocol. Now, there is one little gotcha with it, is that this does not apply for traffic coming from the device itself. And what do I mean by that? Let's say I have ACLs that are blocking all of the SSH traffic going out of these interfaces right here. If I'm originating an SSH session from this router to another router, it will still be allowed because it's originating from the device itself. So just realize that it excludes the traffic coming from the device itself. Now, a lot of times your ACLs, the two are actually going to line up. Whereas you stop the traffic early and you put it where you really want to have your control over security. So in this network right here, a lot of what we're trying to block is traffic from the outside to the inside. And so the ACL would go on this interface, and it would be for the traffic that's coming into that router. So that's where we would place that ACL on there. It also happens to be a very secure place to put it because that's where I want to control access to the rest of the network. So a lot of what you would place in this particular network would go right here on this interface. Access control lists are actually really fun to work with, and we're going to get a chance to get into those demos soon. But with the access control list, they're a list. They're a list of access control entries or access control statements. And so you have this list right here, and there are both standard lists and extended lists. The standard list just has the source IP address versus an extended. You can specify the port, you can specify the protocol, you can specify both the source and destination IP address. So you get a lot more granular with that. We talked about the process and how what your router is going to do is it's going to go line by line and try to match that packet up with each of the lines. Once it finds a match, then it's going to take that action, which is going to be a permit or deny. And it's not going to do any more processing of the ACL after that. So then we talked about the creation guidelines and how you need to go through and make sure your access control lists line up with your policies, make sure you type it out, make sure you have somebody look it over, and you apply it to that right port. Make sure it's putting in on the right port. So there you have it. So that's access control list. Once again, now we're going to take a little deeper dive into a standard access list, and we're going to then get to play around with some of these statements and see how it actually gets applied onto our network.